to Python data mining course. I'm Koyuki. I will be talking about the basics of data mining in this tutorial. So there are a few sections. The first one is cluster analysis. We're going to go over how to create clusters based on a data set, and also classification and regression. And then association, correlation, how to detect outliers, and lastly, dimensionality reduction. So let's get started. Section 2.1, cluster analysis. So cluster analysis, in data science, typically there are two big categories. One is supervised learning, the other is unsupervised learning. So cluster analysis is considered as unsupervised learning, meaning you don't have the labels, right? It's unknown data set, meaning the data is unknown, but you will have some features, but you don't know that how the data set or each data point is classified. So let's get started. As you can see that we're using the same single family home values.csv, same data set that we got from Zillow from the first lecture. And then what you can see is that same as before, we're importing Pandas, Seaborn, NumPy, Matplotlib, right? And then sklearn.cluster, right? So from sklearn.cluster, import k-means. So this is where the library that we'll be using for cluster analysis. So sklearn is a really great library, as discussed last time. It has many models that you'll be using. And then, so let's get started. So as usual, we'll load it into Pandas. So panda.pd.read CSV, and then with the CSV file, and then we'll look at the .head, right? df.head, right? We'll actually see how data looks like. It's going to be the same as last time. And I remember we have done something like, info is something that's very useful from last time, right? This will tell you the types of data that you have in this data set, as well as like df.describe. Remember describe. You can actually look at some of the basic stats for numerical features. Okay, so now let's say, even though this data set, remember, it's we're trying to predict estimated value, right? So this is considered as a supervised learning because you already know the outcome. The outcome is known, and then you try to fit a model that will give you the prediction based on these features, right? These features and also the known outcome. However, we want to reposition this problem, right, so that it becomes unsupervised learning, because here we're going to talk about clustering analysis. So let's say df.drop. So I don't know if I've talked about this last time, but we can actually drop any field that we want, right? So estimated value. So this will actually drop a column. You can actually say in place is equal to true, or just assign it back to your df, right? So I want to say, estimated value, estimated, I think I estimated, okay, that's weird, it's giving me, this cannot, okay, so estimated, okay, I got it. So sometimes you have to do this, axis is equal to 1, so like this, right? So you can actually drop it. So this will tell you that, okay, I want to drop the entire column. So axis 1 is doing that for you. So you can actually say df is equal to that, or just say df2, right? Or in this case, we want to say x is equal to that. So say our x is all the columns without this last estimated value, right? And then we can actually create a very simple classification, very simple clustering analysis, right, based on this. So let's say, apologies. So okay, so let's say I want to use, I want to slice this x. Remember, this x is the type of that, so this is actually very useful too. So type of x is, you can see that's data frame, so you can actually slice it, right? Whenever it's a Pandas data frame, you can slice it. So what if I say, I want to use, let's say, because ID, you don't want to include that as your feature, and so forth. I mean, we could have used latitude, longitude, or zip code, but let's say we just want to use, bedrooms, bathrooms, lot size, years built, like this, right? You can actually just copy it over and then pretty much put the field names like this, and then this will pretty much just slice your DF to only include these columns, right? So let's see. Okay, so now we have all these columns, year built, and then maybe we'll do prior sales amount, right? Because that was one of the important features last time we have found that. So then we can say x is equal to this. So now if we look at x, right, you can actually do x.head. You can actually see that x has all these columns, right? And then you can actually say, again, you see some null values. I will fill it with 0. And then do in place is equal to true. Oh, okay, so now this is great. So we prepare our x pretty much as a feature matrix. And now, as you can see, that already rolled down the code. But now we can actually create a bunch of clusters. So the first thing you'll need to do is after you need to initiate a k-mean, right? So in here, you have imported this model, right? So what you need to do is k-mean. And then you want to say how many clusters you want to have. It can be 2, it can be 3, right? So we can actually have it 5, say. So this you wouldn't know until you try it a few times. Like it takes some like iterations for you to understand what is the best number of clusters you want to put in there. So then random state is to for you to get the same results, right? Every time when you run this code, so that you're fixing a seed and then fit of this x, right? And then I want to assign this back to k-mean, right? So that's how this will work. And clusters, my apologies, and clusters. Okay, so now if we just like print out k-mean like this, right? You can actually see k-mean has all this like, okay, algorithm is auto, copy x true, that it has the property of this k-mean model, right? So now we can actually say k-mean, if you just put down k-means, let's put s, right? So that we have, okay, so k-means dot, and then try to click, if you're Mac user, you can just click on tab. So this will actually give you all the functions, like embedded functions or innate functions coming from k-means, right? So this is coming from sklearns, cluster, and then dot k-means. You can see all these, cool functions. First, let's look at labels, right? Let's look at labels. So labels is like, it says the first data point belongs to cluster 1, second data point belongs to cluster 1, and so forth. And then it's up to 4 because it's going to start from 0, right? So you're going to have cluster 0, 1, 2, 3, 4. So in total, 5 clusters. So, okay, that's great. We got a bunch of labels. And then if you look at the length of this, right, because this is an NumPy array. So the length of this should match with the number of record that you have in your X, right? So you can see that it's 15,000, 15,000. The 7 is number of columns that X has, our feature matrix has. All right, great. So now let's do something, right? So let's look at k-means.cluster centers. So this is kind of interesting, right? So this will tell you for each cluster, where is the center? Where is the center for all these like features? So the 1, 2, 3, 4, 5, 6, 7. So you have 7 features in total. And then this will give you the vector, right? It's a vector of in 7-dimension space because you have 7 features. So let's look at, a quick shape of this, right? So you can see the shape is 5, 7. So 5 clusters and then 7 features, right? So then because it's an NumPy array, we can just say, so for first cluster, which is cluster 0, you can see that this is the center. So feature 1, remember, it's, we have, where is X? So let's see. Let's do X.head again. Okay, so this is our X. So bedroom, like number of bedrooms. So you can see that feature 1, the center for cluster 0, feature 1, which is number of bedrooms, is actually 3.3. And then bathroom is actually 3.8.3. And then rooms, number of rooms is actually 8.4, and so forth. And square footage is actually 2600-ish, right? Because it's times 3, so 2600, right? So, and so forth. So you can actually pretty much like think of it as like you can plot it. You're plotting this thing in 7-dimensional space. So actually, we can do something very interesting, right? So because we have the sign from these labels, right? We have array of labels, right? And then each data point gets a label. So we can actually call it labels, right? We are going to assign this, so let's just call it labels. We can say X, this is to assign, remember, a new column, right? We can say the cluster is equal to this labels. So now, if you look at x.head, all right, so you see this newly appended, right, column to the end. You have a new column that's called cluster. Okay, that's great. So what we can do is we can group it by, right? Do some like quick stats. Group by our new cluster that we just got from this k-means that we just created. And then we want to look at, you know, the mean, right? So you can actually see this is pretty much the cluster center. Very, very close to the cluster center. But you can actually see the stats, right? For cluster 0, what is the mean? The average bedroom, bathroom, rooms, square footage, that, right? And then for cluster 1, these are like the average features, right? And then so forth, right? So this is actually very useful, right? And then you can, of course, look at mean, right? And then max, right? And then median, of course, median might be useful. So this is actually very interesting, right? You can actually see quickly can create clusters, and then just using, you know, sklearn's k-mean like this, and then fit it using your feature matrix. This is how you can actually do something, you know, like this quickly, and then append this new cluster, right? The set of clusters back into your feature matrix, and then do some statistical analysis in here like this, right? So now I'm going to give you, since we don't have a lot of time left, but I'm going to give you a quick example that I just copy and pasted from my scalar. So this you can actually find from their source code. But this is to say, I'm going to use, remember the ARIES dataset, the very famous ARIES dataset, right? So I'm going to use that dataset to really create some clusters. So you can see that it's using k-mean, sklearn.cluster import k-means, right? It's using the same model, but it's going to be fitted differently because the data, underlying data is different. And then you can see that, you can visualize, this is a great visualization here. So you have, if it's 8 clusters, then this is how it looks like, right? Different, right? And then if it's like 3 clusters, this is how roughly it looks like, right? And then 3 clusters with like bad initiation, and then so forth, right? So like I said, initiation is something that's very important as well, like how do you initiate your models, but we're going to actually talk about it later. But this is the way that you can pretty much grid search, like as opposed in terms of number of clusters, like say 8 cluster, 3 cluster, you know, or 5 clusters, right? So definitely you have to do some inspections to determine what would be the best number of clusters that you want to use. But once you have this code ready somewhere like in here, you can just pretty much write a for loop that will do, you know, look at different number of clusters, right? So let's quickly maybe do that, right? So we can actually say, you know, for I in say range of say we want to do it from up to 10, right? So from say 3 to 10, right? Then we want to do this k-means of n clusters is equal to I, right? Because that's what you're iterating through, and that fit of the same X, right? And then we'll have to drop the cluster first, I believe. And then I will, okay, so like this, and then I will say this is equal to. So I'm just putting what we have created before into a for loop so that this is how you can, to show you how you can grid search in terms of number of clusters, right? So, and then you can look at, for instance, K means the labels. So then we can print out, all these things. And then, okay, so this is how you can actually write a for loop and to do something, right? So, and there is always a score. Let me Google the score that you can use to in scalar. Scalar and then silhouette. I think it's called silhouette score, right? So this is a score that you can use to really tell if your clusters are the stickiness of the cluster, meaning like the degree of clusterness in the cluster. So this is a good way of telling if the number that you're setting in here, right, in your cluster initiation here is a good number of cluster or not, right? So yeah, so that's, you can actually, let's just maybe try this, right? So we can try it in here. Let's say we need to import it first, like we can just import it in here. Let's give me this. Okay, so let's see. Right, so remember, you can actually just do from, and then when you do that is import, right? So let's see, we can use score of your, let's see, I always go back to the documentation just because it's very, very useful. I don't typically remember everything. So yeah, it tells you like you'll have to pass your X, which is a feature, right? Like our feature matrix and labels, right? So the two things you need to pass is X and then labels, but our labels is k-means, I guess we don't need to print this. We can just call this labels, assign this as a label, is equal to that, and then we want to print out, right, this, and then we don't want to print out the score. Okay, so let's see, right? Yeah, it's just taking some time. Yeah, it's very slow, but this will tell you, the higher the better, definitely. Yeah, so this is the first one, right? You can actually see with 3, this is like the silhouette score for 3. And then by default, if you don't pass anything, it's going to use Euclidean distance. So, and it says it computes the mean silhouette coefficient of all samples. Okay, so the difference is, small in here, but it's going up. Okay, so let's just let it run. And then this is in our section 2.1, we talk about cluster analysis, how to use sklearn's k-means to create a simple cluster model. Thank you. And then we're going to continue to 2.2.